Welcome to Tomorrow Unveiled. For those of you who track the cutting edge of robotics, well, this past week, September 2nd to 9th, 2025, wasn't just another update. It felt like, I don't know, a seismic acceleration. We've really seen a confluence of breakthroughs and deployments that seem to be reshaping the landscape of humanoid robotics.
Yeah, it's been an unprecedented 7 days, truly. It signals a new phase, I think.
Yeah.
Our mission for you, our informed listener, is to really move beyond just the headlines. We're going to dive deep into the underlying forces, the surprising implications, and the crucial connections that maybe explain why this specific week has been so pivotal for humanoids. Our dedicated research team has sifted through a whole stack of compelling reports, academic research, industry announcements, all to bring you the most potent nuggets of insight.
Okay, let's unpack this then. We've witnessed this remarkable convergence. You've got AI advancements, actual commercial deployments, massive international investments, all hitting at once in humanoid robotics. It really feels like the field is rapidly shifting, moving from, fascinating lab prototypes to actual commercial viability. But the big question for many people, I suspect, is why humanoids? Why this intense focus on robots shaped like us instead of, say, maybe more obviously efficient wheeled machines?
That's a great question. And what's truly fascinating here is that the emphasis on humanoid robotics isn't just about, like, making them look like us. It stems from a profound practical advantage. Humanoids possess this unique ability to navigate and operate within environments already designed for humans. Just think about it for a second. Stairs, door handles, existing tools, even just the height of a workbench. A wheeled or tracked robot might be great at specific tasks, sure, but a humanoid is built, fundamentally, to handle the inherent messiness and variety of our world. This versatility really makes them the most promising platform for the next generation of AI-powered automation, especially for what our research team calls the long tail of unstructured tasks.
Right, that long tail concept, that feels really important here. So it's not just about flashy tech demos, it's about unlocking the vast majority of tasks and spaces already built for people. And this isn't just a tech fascination either, is it? We're talking about a massive economic bet being placed here. What are the numbers telling us?
Oh, absolutely. The research team sources highlight some, frankly, staggering market projections. We're looking at a potential global market reaching something like $38 billion by 2035. And the annual shipments of new robots are expected to just skyrocket. To give you a sense of scale, major players like Tesla, for instance, are reportedly viewing their humanoid programs, Optimus in their case, as potentially accounting for a significant chunk, some reports say upwards of 80% of their long-term valuation.
80%, wow.
Yeah, so this isn't just some speculative side venture. It's seen as, potentially, a multi-trillion-dollar economic imperative, automating industries previously untouched by traditional robotics.
That kind of economic potential is genuinely a game changer. And it seems the real engine driving this revolution isn't just the hardware, the metal and wires, but something profoundly new happening in AI. This is where it gets really interesting, I think. The brains behind the Brawn. We're hearing about a kind of chat GPT moment for robotics. Can you elaborate on that comparison?
Precisely. That's a good way to put it. We're seeing advanced AI, particularly these large-scale foundation models, essentially, the advanced large language models, LLMs rapidly becoming the central nervous system for these next-gen robots. And this represents a fundamental shift, a huge shift from rigid, pre-programmed instructions, do step A, then step B, towards fluid, intelligent reasoning. Instead of just being given a finite list of commands, they're starting to understand intent and reason about tasks in a way that, well, mimics human common sense.
And we saw a pretty striking example of this conversational AI in action just this week, right? With Tesla's Optimus V2.5 prototype integrating Grok AI. The demonstration showed the robot understanding and responding to natural language commands. So it wasn't just recognizing the word Coke, but actually interpreting the request, get me a Coke.
Yep.
And then crucially, formulating a whole multi-step plan to actually fetch it, navigating, opening a fridge, selecting the item. That's a massive leap beyond simple voice commands, isn't it?
It is a profound shift. Absolutely. It highlights this new paradigm where the robot can understand intent, not just keywords. It can engage in a kind of conversational loop, ask clarifying questions maybe, and act more like a partner than just a tool. If we connect this to the bigger picture, this architecture often involves a modular Brawn, that's the physical robot hardware, and the AI, often an LLM. The LLM acts as a sort of common sense reasoning engine. Think of it like the robot having access to this enormous library of human knowledge and understanding. It allows it to infer what you really mean by get me a Coke, not just as a fixed command, but understanding the context, where a Coke might be, the steps to retrieve it safely. This is absolutely crucial for handling that long tail of real-world tasks that you simply cannot pre-program solutions for.
That ability to infer intent to bridge that gap between a high-level human goal, like tidy the room, and the actual low-level motor commands needed to pick up objects, that really feels like the holy grail. But how are these machines learning to navigate and interact with our incredibly messy, unpredictable physical world? It's one thing to reason, another to act. Our research team dug into two fascinating papers this week that offer a glimpse into tackling that very challenge. One focused on learning to walk in costume. That sounds a bit whimsical.
It does sound whimsical, but what's truly innovative here is how researchers are using these learning-based methods to compensate for, well, suboptimal physical designs. This isn't just about making robots look cool or entertaining, though that's part of it. It's about solving the incredibly difficult problem of achieving stable, natural movement when the robot's physical design is intentionally not perfectly optimized for locomotion. Imagine, like, trying to walk gracefully in a big, top-heavy mascot costume. It's hard. This research allows the robot's AI to essentially learn how to balance and move naturally despite those inherent mechanical challenges. And that opens doors for robots designed for entertainment or maybe companionship, where aesthetics and character are really key, not just pure mechanical efficiency.
Okay, so it's pushing the control algorithms to let form and character drive the design, not just pure engineering function. That makes sense. And the other paper, Interactive Shaping of Granular Media, that dealt with robots learning to interact with unpredictable, non-rigid stuff like sand using reinforcement learning. That seems critical for moving beyond just handling solid objects.
Indeed, massively critical. This is a huge step toward humanoids handling the messy, real-world materials we encounter every day. Think construction sites with gravel, farms with soil, disaster relief with debris, or even just complex household chores like folding laundry. Most robotics research historically has focused on interacting with rigid, predictable objects, blocks, tools, things like that. But our world is full of sand, dirt, fabric, liquids, all sorts of unpredictably changing substances. This learning-based approach to manipulating non-rigid materials is really foundational for achieving true human-like dexterity and versatility.
It's incredible to see how quickly these breakthroughs seem to be moving from the lab environment into real life. What's truly astonishing this week, I think, is how quickly these cutting-edge capabilities are moving from that theoretical research stage into actual real-world deployments.
Absolutely. The pace is picking up. We're seeing significant pilot programs launching. For example, in warehouses, agility robotics digit humanoids, the ones without a head, focusing on mobility, are already working shifts at Amazon facilities, moving bins, handling materials. And these mark some of the first confirmed deployments in active commercial operations, not just controlled trials.
Right, so no longer just tests behind closed doors, but actual work being performed alongside human workers. And what about in factories, where precision is absolutely paramount?
Yeah, good question. Hyundai Motor Group is beginning what they call large-scale deployment of learning-based humanoids, like the Boston Dynamics Atlas in its Georgia facility. And BMW has conducted successful trials with Figure O2 humanoids performing really complex assembly work, things like inserting sheet metal parts into chassis fixtures with millimeter-level precision. That kind of task, requiring two-handed dexterity and fine control, was previously considered pretty much beyond humanoid capabilities in a demanding factory setting.
Millimeter precision? And even in our homes, that feels like such a huge step towards personal robotics, and frankly, potentially a game changer for daily life if it ever becomes commonplace.
It does feel closer now. Figure AI demonstrated its Helix humanoid performing household chores, like loading a dishwasher, which, let's be honest, many humans struggle with. Other prototypes, like 1X's Neo, are being tested in home environments too. Often initially, with human teleoperations, someone driving the robot remotely to gather crucial data for training future autonomous tasks. Things like watering plants or serving drinks. And hey, for our listeners on YouTube, if you're finding this insightful, please do take a moment to like this video, subscribe to Tomorrow Unveiled, and maybe consider hitting that new hype button. It really helps us reach more viewers. And of course, turn on notifications so you never miss an update on the future. But back to the point, these pilot programs, even the teleoperated ones, are just crucial for collecting that real-world data and refining those generalist capabilities needed for the home.
And this isn't just a Western phenomenon either, is it? The research our team compiled highlights this as a truly global ecosystem taking shape.
Oh, absolutely. The recent World Robotics Conference in Beijing, for instance, showcased over 60 different humanoid robots from various Chinese companies. This signals a massive national investment by China. Their focus seems to be particularly on manufacturing, logistics, healthcare, and significantly elderly care. It reflects, I think, both strategic effort to address their own demographic challenges and a clear ambition to establish technological leadership in this area.
Which brings us to a really fascinating distinction that was highlighted in the week's events. This sort of tale of two robots, the generalists versus the specialists. It seems both types are advancing rapidly, but in different directions.
That's right. It's a key point. On the specialist side, you have examples like Universal Robots unveiling its UR8 long cobot. Now, a cobot means it's a collaborative robot designed specifically to work safely alongside humans. This UR8 is a specialized industrial arm. It's got an extended reach, high payload capacity. It's designed for high-precision repetitive tasks. Think welding, machine tending, things like that, in a controlled factory environment. It's built to do one thing or a small set of things exceptionally well.
Okay, the industrial workhorse. And then on a more critical, maybe even life-saving note, there was news about DARPA's MASH program.
Right. MASH aims to develop sensor-guided, AI-driven robotic systems for autonomous surgical procedures specifically. To stop internal bleeding on the battlefield, you couldn't get much more specialized than that. It's the ultimate specialist for a very narrow, incredibly critical mission.
So you have these highly specialized machines on one hand.
And then on the other hand, you have the humanoids. And what's fascinating here is that humanoid robots are really the ultimate generalists. They aren't designed generally to be the absolute best at any one specific task. Instead, the goal is for them to be good enough at a vast variety of tasks, specifically in environments built for humans. They aim to fill that huge economic niche of unstructured, human-centric environments. Think small businesses, hospitals, construction sites, eventually our homes. A market that's been largely inaccessible to traditional specialized automation until now.
So it's not really about replacing human jobs one for one with a robot doing the exact same thing better, but maybe automating tasks that weren't automatable before.
Exactly. Or augmenting human capabilities.
Yeah.
It's potentially creating entirely new categories of automated service and assistance.
So they sound like complementary forces then, rather than necessarily competing directly with those specialized robots. Like you wouldn't use a humanoid for high-speed welding if a specialized arm can do it faster and cheaper.
Precisely. It sounds like a maturing market, where both types of robots will clearly have their place. The simultaneous advancement of both really reveals that. Humanoids are expected to complement, definitely not entirely replace, specialized robots in many settings. In fact, some systems are even being designed explicitly for collaboration. Our research team noted Agility's Digit, the humanoid, is sometimes deployed working alongside wheeled autonomous mobile robots, AMRs, in warehouse settings, each doing the tasks they're best suited for.
Okay, that makes sense. Which brings us to the global race and, well, the formidable hurdles that still remain. It's clear there's intense competition underway.
Oh, an intense technology race is certainly heating up. You have the United States with prominent companies like Tesla and Figure AI pushing hard. And then you have China with players like Unitree and UBTech, often backed by significant state funding, pouring resources into humanoid robotics. China's strategy, interestingly, seems to emphasize affordability and scale quite heavily. Some Chinese humanoids, like the Unitree G1, are reportedly being offered for around $16,000.
$16,000. That's remarkably low compared to what we might expect.
It is, and that puts immense pressure on their Western counterparts, naturally. It also signals a potential future where these robots could become much more widespread, much faster, if that price point holds its scale.
But despite all the rapid progress and these really ambitious goals, formidable challenges definitely remain. Where are the biggest bottlenecks right now, based on the research?
Yeah, that raises a really important question. Progress is fast, but the hurdles are still significant. The hardware, the physical brawn, still seems to lag behind the AI brain in some key areas. Battery technology, for instance, is a big one. It only allows about maybe 5 hours of peak performance for some of the more advanced humanoids currently. That's critically insufficient for a full industrial work shift.
Right, you can't just swap them out every few hours easily in many scenarios.
Exactly. Then there's the massive hurdle of actually scaling up production and getting the cost down. No company today is producing humanoids at the kind of mass scale that's needed for widespread adoption. Ambitious targets exist. You hear numbers like Figure AI aiming for 100,000 units in 4 years, or Tesla talking about millions eventually but achieving an affordable unit price, like Elon Musk's target of $20,000 for Optimus, requires massive economies of scale and manufacturing innovation that, well, we haven't actually seen materialize yet.
And dexterity is always a challenge, isn't it? Trying to replicate the human hand is notoriously difficult.
Absolutely. It's one of the hardest problems. Robotic hands and the sensors embedded within them still lack the sheer delicacy, the strength, and importantly, the rich sensory feedback of human hands. This makes fine motor control exceptionally difficult. Picking up an egg without crushing it, manipulating a delicate circuit board, even tying a knot. These things require an almost intuitive sense of force and texture that current robotics are still really struggling to master reliably.
And perhaps the most crucial challenge, especially as these robots start moving out of controlled labs and factories and into public spaces, or even our homes, safety and regulation. What are the societal implications here, beyond just the technical nuts and bolts?
This might be the greatest challenge of all, honestly. Bipedal robots, just by their nature, are inherently less stable than wheeled ones. They can fall, and if they're large and heavy, they can pose real risks. Developing new safety standards, rigorous testing protocols, robust fail-safes, all that is absolutely crucial, especially given the very real psychological risk of human overtrust.
Overtrust, meaning we assume they're more capable than they are.
Exactly. People might mistakenly assume a human-shaped robot is as aware, as sensible, as capable as an actual person, just because it looks like one. This could lead to dangerous situations if the robot malfunctions, or simply lacks the common sense programmed into it to avoid a collision or navigate an unexpected obstacle safely. This isn't just a technical problem, it's a profound societal and psychological one. It demands really careful consideration as these machines become more common. And for those of you listening on a podcast service like Apple Podcasts or Spotify, if you're enjoying Tomorrow Unveiled, we'd be incredibly grateful if you could leave us a rating and review. It genuinely helps us reach new listeners.
So wrapping this up, what does this all mean? What really stands out from this week's deep dive, for me at least, is that humanoid robotics seems to be in the midst of this profound growth spurt. It really echoes the early days of the internet or smartphones, maybe. The AI brain feels undeniably ready, or very nearly ready, to handle complex reasoning and understand intent. And now the global race is truly on to build a cheap, reliable, and critically safe physical body that can actually operate effectively in our world.
I think that's a great summary. Looking ahead based on the research team's findings, we can definitely expect to see an increasing number of pilot programs popping up in warehouses, stores, maybe even more home trials over the coming months. And alongside that, continued rapid iteration on the AI capabilities. This isn't some far-off future that's decades away anymore. It feels like it's unfolding now, week by week, right before our eyes.
Indeed, and we love hearing your thoughts on this. Whether you're on YouTube or your favorite podcast app, please leave a comment and let us know what you think about this rise of humanoid robots. As these machines become more capable and more integrated into our lives, what do you think will be the biggest challenge, or perhaps the greatest opportunity, in truly bringing them into our daily lives? Will humanoids primarily remain these advanced but specialized industrial tools, or will they truly become ubiquitous personal assistants, fundamentally transforming society, maybe even within the next decade? That's definitely a question for all of us to consider as we watch this incredible future unfold.